Hi everyone, I'm making this video to talk more about growth in tech careers. Salaries in tech, especially in India, are very diverse. Just on entry level alone, you have companies that pay like 2 lakhs per annum, and at the same time, you have companies that pay like 40 lakhs, even in a bad market. So, a gap of 20x. And this gap only becomes wider and wider with more experience, especially if you're not growing in your role. And what's the then way to move up in this ladder and bridge this gap? The only way to do that is by building the right skills and capabilities. Hi, I'm Anshuman Singh, and I'm making this video to deep dive into what it takes for you to grow in your career. I also then want to take you through the scalar curriculum to talk more about how the curriculum actually bridges the gap that I'm talking about. I believe the scalar curriculum is one of the most comprehensive curriculum for your path, but then I'll also show you that. I'm assuming you are a junior backend developer. If you're not, then depending on who you are, there are links in the description of this video. Please go and click on that link and then move to that video. If you're staying back, I'm going to assume that you are a junior backend developer. Now, why am I making this video? I'm making this video assuming that you want to grow in your career, um, and you're going to be targeting SD1, 2, or 3 kind of backend roles at product companies. Now, firstly, before I do that, I want to talk about why I have seen people fail in junior backend roles to move up. One of the primary reasons of failure is, and I'll talk about both kinds of failure, like in interviews as well as work. In interviews, I see people fail because they're not good at DSA. Now, you would ask, why is DSA required? Look, I mean, everything that you see built around you uses some or the other form of DSA, right? For example, you use cache. If I say, hey, go and implement LRU cache yourself, don't use an existing library, that will require DSA. You might have used Linux. In Linux, you have that diff function, right? It helps you differentiate two files, finds out the difference between two files. If I ask you to implement diff, requires DSA. If I ask you to implement a spell checker yourself, requires DSA. If I ask you to, let's say, find the shortest path between two different cities, or let's say implement a basic Google map, requires DSA. So DSA is all around you. Hence, companies also index on that. Again, most people are not very good on DSA, hence end up failing there. Two is, chances are wherever you'll be working on a multi-threaded setup. So being very, very aware of what kind of race conditions exist, how do you synchronize code, concurrent data structures, very important. Mutex semaphore, important. Most people are not there, hence they fail. Or I mean, being comfortable with working with relational DBs, being able to write complex queries. For example, I see most people don't know about window functions. Most people don't know about transactions or isolation levels. If I just ask them, hey, look, if I have to maintain a YouTube counter, what kind of isolation level will you use? People go blank. Um, or just, I mean, going deeper into the tech stack that you currently use. I believe engineers should be tech agnostic. However, I mean, for something that you've been using for the past 2 years, 3 years, if I ask you questions on that language, you should be comfortable. For example, if you've been using Java, then I would expect you to know about Java collections or streams or lambdas. If you don't know that, that again becomes a reason of failure. In the earlier market, I would not have cared about design, but in this market where companies are very selective, I see people indexing on design as well, and that's where people fail. Now, within design, I would want to index on what is the kind of work you've done in the past. Do you understand why components were built the way they were? How would you change it if you were to change it? If I pick one component, for example, let's say I pick MongoDB, if you had used MongoDB, and I say, hey, look, why did you use MongoDB? Why not something else? How would you shard a MongoDB? How would you scale a MongoDB? How do I make search faster in MongoDB? How to do indexing in MongoDB? If you don't know the answers to those, that again becomes a red flag for me. Very similarly, if I ask you, hey, let's go and build a book my show. Software engineering is not just about making something which is functional, it's also about building it the right way. So how would you build the schema? How would I build the API? What would my class structure look like? What is the design pattern that I'm using? Again, I see people faltering there. I again, most junior backend developers are not expected to be very good on architectural design, which is HLD, but basic design is expected of them. If asked to design, let's say, a rate limiter, which is, to be honest, like a glorified DSA problem, um, Or if asked to, let's say, build a distributed ID generator, are they able to do that or not? If asked to build, let's say, a basic URL shortener, are they able to do that or not? Again, understanding of tech stack. Let's say, for example, if you use Java Spring Boot, then understanding of that, again, very important. Some companies now are also adopting microservices, so they tend to ask questions on microservices, design patterns, for example. For example, if a request is going through multiple microservices, now how do I know where the request failed if the request failed? Which is, how do you do distributed tracing, for example? How do you maintain versions in API? If you were to design an API management system, how would you build that? All of those are the questions which our companies are asking, but most people falter on. That is for the interviews. Then people get to work. In work, again, I see that there are gaps because people, I mean, today identify themselves as a Java developer or a Python developer, which means I know everything about my language because I was taught that somewhere. But then when it comes to learning new stuff, I struggle there, which becomes a problem or a hindrance on your growth. Chances are you'll be given problem statements where you might have to be asked to work with a different team which is working on a different tech stack. In that case, you can't just say that, look, I am a Java developer, I will not go and code in Python, or vice versa. People do that. When there is a new technology, people make a big hype about it instead of understanding what is the art of learning. How do you learn something really quickly? People, everything is built with similar patterns. How do you identify those patterns? How do you learn quickly? How do you troubleshoot production issues? How do I log into another machine, find out through logs and processes what might have gone wrong? Those is where people fail. And to be honest, that is what you need to learn. I mean, you need to learn DSA, you need to learn concurrency, SQL, Java. I mean, Java, if your Java was your language, but I mean, irrespective, your own language in depth. Design, previous work X design patterns, machine coding rounds, which is where you have to build some prototype very quickly. Schema design, API design, HLD, microservices. You might have questions around cultural fit, etc., as well, which I'm sure you'll do well on. And then, I mean, how do you do well at work? How do you build this habit of learning quickly? If you do those two really well, if you are aware of, let's say, the right kind of patterns around observability tools, how to build the right alarms, um, then I mean, then you're a complete backend engineer, and then I mean, your growth becomes much simpler. You'll be able to do well in interviews. You'll be able to do well at job. And if that is the baseline, then how do I learn all of this stuff? Where do I get started from? And that is exactly what I'm going to walk you through. Um, that for success in interviews and work both, a step by step curriculum which will help you succeed in your role now and in the future as well. Learn it once, but it stays with you for life. Now we come to the curriculum. Now, for while Scalar actually offers backend track, full stack track, data engineering track, etc., for you, my recommendation would be stick to backend. Better to go more deep rather than going too broad. So, if that's the case, let's actually go over what the curriculum looks like and how it solves for what you need for interviews and or for job efficiency. Uh, no surprises. The first module is DSA, which goes on for 5 months. Very comprehensive. All topics are covered. Every class is followed by a set of assignments, which are coding questions, very similar to the interview coding questions, but you get to practice it, you get to solve it yourself. The idea with this module is that how do we build your problem solving ability? The idea here is not to dictate solutions to you. The idea here is not to give code to you, but rather build that part of your mind which can think of innovative solutions when they get a new solution, right? So building that part of your muscle. Now, the relevance for interview is very clear. Look, I mean, 2 or 3 of your rounds are going to be on DSS, so it is definitely very, very important. One other thing, however, is that look, it also helps with job in ways you might not have thought of. For example, if you do DSA, I mean, one of the things you get really good at is your accuracy of coding. You try to get your code right the first time. Now, if that happens, then you make lesser bugs, your productivity increases. Two is it develops a mindset where you think, like by default, think of efficient solutions. Writing solutions which are not efficient almost gives you cringe. Three is when you start to learn about system design and large scale systems, when you get deeper into their architecture, you start to realize that all databases, all large scale systems, they actually under the hood use a lot of DSA. So understanding those systems then becomes easy for you if your DSA knowledge is solid. For example, like something as simple as a relational database uses B plus trees under the hood. If you know how trees work, understanding B plus trees and then how a database works becomes super simple. Now, one of the assumption here is that look, you already know coding. If you don't, then like for beginners, which is if you're a beginner, then there is a 2 month of teaching you a programming language before DSA, which is in Java. However, I mean for you, I'm assuming that's not the case, and hence we directly start with DSA. The module after that is relational databases, which goes on for a month. Um, Now, this module, the primary use case of this module is look, it will teach you to be good at schema design, indexing. So, essentially, what kind of indexes to build, or if there's an index, then like what kind of queries does it affect? Transactions and isolation levels, which is to say, hey, look, I mean, what kind of locking or isolation level do I need for a given use case? How does it affect my performance? Writing complex queries, I see a lot of people fail when they have to write queries that involve window functions, etc. In fact, even as soon as the queries get more complicated with more joins, people start to struggle. Again, as an engineer, you're expected to be able to write complex SQL queries, so that gets covered. So you have joins, aggregation, window functions, subqueries, views, CRUD, etc. um, and I mean, this helps because in your interviews you're going to be questioned on schema design. You're going to be questioned on writing certain SQL queries, indexing and transactions. In fact, maybe a deeper dive on like how things are stored internally inside a relational DB. You might also ask me the question, hey, look, this is relational DB SQL, but what about NoSQL? Don't worry, NoSQL is covered in system design module and the advanced project module, which we will talk about later. At work, this is important because 90% chances are a lot of systems you'll be working with use relational DB in the background. So if you're building for relational DB, it's obviously good to be solid with that. You should know what kind of schemas work best. You should know how to run queries, how to fetch information, what should have index. Otherwise, your system will become really, really slow. Once you're done with that, then there's an optional module of a month, which is project. Um, Now, this project module is optional because one of the things I'm assuming is all of you have prior experience in backend. You would have built some project. But reason why I say that it is optional also is that there's some of you. I mean, in India, like the experiences are very varied. Like, so it is not necessary that you have done decent project work either. If you have, great. If you have not, then please do this module. This module basically covers basics of Git, um, basics of a framework, in this case Java Spring Boot, REST APIs, how to handle exception, um, how to build authentication systems, um, how to do schema versioning, how to get started with cloud on AWS, for example. How do you set up EC2, RDS, basic deployment processes, VPC, DNS. How do you set up metrics and measurements? How do you integrate an external API, especially like something which can become very complex? So, for example, payment gateway. Integrating gateway is the real deal. So, we help you integrate a payment gateway here. Um, Pagination, searching string. How do you optimize your APIs? All of that is covered in the project module. Now, you'll notice that this is done in Java Spring Boot. And I'll go back to what I said earlier, that as an engineer, um, you have to be language agnostic. You have to be tech stack agnostic. You have to be open to learn new tech stack when required. So by just doing a project in Java Spring Boot, even if you're not a Java coder, it helps you unlock more opportunities instead of doing any harm. So my recommendation would be please learn and do it. However, if you have reservations, if you say that, look, I do not want to learn a new tech stack, however, I still want to do a project module, in those cases, a bunch of concepts that are covered here, they are language agnostic. For example, how to do authentication, schema versioning, how to set up cloud, etc., 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 is all language agnostic. Whichever part is related to the language, there we also give you recordings in different languages. We also give you documentation in different languages. And in this module, the assignments also support Java and Python. So there are assignments where you have to build a feature. There are assignments where you have to, let's say, build an extension of what was covered in the class. um, and as you, let's say, do those assignments, we have unit test cases, etc., which are run to judge whether your things are working well or not. Those support both Java and Python, and hence your project happens from there. Now, this is helpful in the interviews because, firstly, projects or high quality of projects help with resume shortlisting. I'm sure like your previous experience helps there. But there are questions on MVC frameworks. There are questions on like how certain things work. For example, authentication, or let's say how certain things might work um, in the context of schema versioning, exception handling, etc. So you'll be able to handle that. In general, this is backbone of your job, right? This is what you'll be doing day in day out. The one other thing that I also want to mention on the assignment piece. For example, in the last module, I mentioned that you'll be doing schema design. Here, you might also be doing API design in projects. All of those also have assignments. So we have actually integrated AI to be able to do these kind of assignments where you create a schema design and we are able to then give feedback and scoring or suggestions based on leveraging the recent LLM models that we have. Anyway, moving on. Post that, we have advanced language. Again, there we covered OOPS, concurrency. Concurrency is multi-threading, and like language advanced concepts. Now, in multi-threading, you have to think of like, look, I mean, how do, let's say, multiple threads coordinate between themselves? If I want one thread to do something, another thread to do something, and like I want them to be able to uh, multiplex in some ways, then how does that happen? How does synchronization happen? How do mutex and semaphores work? All of that is part of your concurrency module. Um, so post this module, you'll be able to comfortably think about when, in what cases race conditions might occur, what are concurrent data structures, and how do you synchronize a piece of code. um, Post that, there is advanced concepts in a language. We do live classes for Java for certain advanced concepts. However, again, if you're from a different language and you want to go deeper there, we share recordings as well as documentation of certain questions that are likely to be asked in the interviews, or likely that you will end up using in your job frequent times. So as long as you have that as a cheat sheet, you can just keep referring to that. Post the advanced language module, which is of a month. By the way, just also mentioning here the assignments, all kinds, right? So we basically have MCQ assignments, we have coding assignments, we have these assignments where there are unit test cases that are written, there are certain AI driven assignments. A bunch of those assignments here like exist here as well. For example, for multi-threading, we give you assignments where there might be race conditions, or maybe where we have multiple threads and we want you to be able to coordinate between those threads. Post the advanced language, there is the low level design module. Now, again, I can talk about a bunch of these design patterns that are written here and like a bunch of these case studies written here, but let me tell you where people fail here, and hence it derives what is there in this. We see that most companies, they focus on three kind of interviewing rounds for low level design. One is knowledge based, so they would just straight up ask, hey, look, what is singleton design pattern, or what is a adapter design pattern, or what is a factory design pattern. um, there are some companies who would not do that. In fact, better companies don't tend to do that. They would rather give you a case study. They would say, hey, look, I want to build a book my show, or I want to, let's say, design a software for a parking lot. How should I go about doing that? And you're required to sort of gather all kind of requirements, and then maybe build the right class hierarchy, build the right kind of schema. And that's where you'll be using some of these design patterns to make sure you're following the right practice. And the third kind of rounds, which typically happens with companies like Flipkart, Udan, etc., is the machine coding round, where you will be asked to build a prototype of a basic um application like Book My Show or Splitwise or Google Calendar. There, your schema design, your API design, your class design, all will be tested. And you don't have a lot of time to do that. You probably have like 90 minutes to build a basic prototype. Need not look great as long as it is functional. And there, what you're judged on is how did you design the schema, API, and class architecture. Keeping that in mind, everything that is required for that is covered as part of this low level design module. Um, Chances are either at SD 1, 2, 3, whatever kind of interviews you go for, you will be judged on low level design. It also helps you at work because this helps you write the right kind of maintainable, extendable code in your company. It helps you do the right kind of code reviews, just to make sure you're not only building for today, you're building something that will last for later as well. Assignments here, again, very similar kind. Either asking you to build something where unit test cases already exist, um, or maybe helping you, asking you to design a class architecture, which again is just through AI. So a combination of both, and in some cases maybe some MCQs as well. Every class, however, has assignments. Finally, actually, second last is the advanced software engineering module. This is where we try to get you familiar with the larger systems that you might be likely to work with. In fact, most companies expect you to know certain things about these kind of systems, right? So for example, as I said, a lot of companies have recently started asking a lot of questions on microservices and their design patterns. And we try to get you hands on there. Certain companies ask questions on Kafka. For example, how do you scale Kafka on a particular topic? Essentially, how do you create multiple partitions? How do you have more consumer groups? Now, you can't do all of that unless you've done something which is hands on with Kafka. Or how do you do, let's say, a full text search? Now, for that, you have to use Elasticsearch, but then, like, how do you build a basic index on Elasticsearch, etc.? So again, we try to get you hands on those things. How does an internet work? Right. So, what happens, let's say, when you type google.com and press enter? Um, more from from a networking standpoint. Um, all of those is covered here. So we cover things around Elasticsearch, messaging queues, Kafka, networking, microservices, basic Spring Cloud, logging monitoring, containerization like Docker. Now, while this is very relevant to interviews, it's extremely relevant for work as well. Chances are all of this will be relevant for your work wherever you go. Um, Now, one of the other things, by the way, one of the other philosophies that is, by the way, driving this module is that through this module, one of the things we will push you for is reading documentation and learning from the documentation. We are there to help you, but here and in some of the earlier modules, we try to build the habit of also learning on your own, so that by the time you're done with Scala, it's not that then uh, you're in the habit of being spoon fed. You also have to become self capable, right? So we try to push you more aggressively on this path where you start to learn on your own as well. The assignments here again very similar. Implement feature, build something, and we have test cases around that. If you're building something on Kafka, again test cases around that. Post that, the last module is the architectural design or system design HLD module. Again, we start with the building blocks, caching, cap theorem, master slave, multi-master, no SQL databases again, and why what they needed, and then like what's their architecture like for different kind of NoSQL databases. Again, we, for example, we get into Cassandra's architecture. Um, and then we do a bunch of case studies. So Google search type ahead, Messenger, um, like Google Maps slash Zomato, Uber, Hotstar. We do certain smaller case studies as well. For example, rate limiting system or distributed ID generator. Um, or I mean, we try to also design certain systems that we exist. For example, Kafka, Elasticsearch, Zookeeper. Like, how would you, if that was posed as a design problem statement to you, how would you have gone about designing it in a way where it scales, it's capable of scaling? Now, again, this is where the assignments are designed in a way where you're given situations, and in those situations, what is the right answer? Mostly MCQs, or like a number as an answer, which if you understand the design well, then you'll be able to answer. This is extremely relevant for all kind of system design rounds, all architectural design rounds in the interview. However, I mean, it is also important at work, because without this, to be honest, your progression to senior engineering roles is impossible. You have to be able to participate in team design discussions. It is in a way prerequisite for promotions. Um, and I mean, the part about being able to solve ambiguous problem statement doesn't happen unless and until you understand architectural design pretty well. You have a good hold on that. Once you're done with that, that's your mandatory part of the curriculum done. You also have two electives. Again, you can choose not to do them. However, if you ask me, I would suggest please do the elective on product management for engineers. This actually trains you to be able to take a problem statement, think of it from a product first standpoint, break it down into small parts, makes you good at solving ambiguous problem statements. Hence that elective is there. The second elective is data engineering elective. This is very relevant if, imagine, your company does deal with a lot of data. Sometimes you will get to work with data engineering teams, data engineers. You might be involved in a data migration. You might be involved in setting up a data warehouse. In those cases, having gone through this module, that journey will become super easy. In fact, if later you want to become a data engineer or just explore it, again, becomes super easy. Um, Now, this is the rough overview of the curriculum. However, just the curriculum itself does not really help. It gives you structure but doesn't help. I'll tell you what exactly helps. Firstly, I talked about assignments. They really help because they help you apply everything that you've learned. Two is the biggest problem that I hear from everybody is completion, which is people start on this journey but never complete. Now, for completion, what helps? So, firstly, we do live classes so that there is some schedule that is enforced. Um, in a way, we help you build that discipline, and you have somebody you can ask questions to. So that helps. Third thing is you're not doing it alone. You're doing it in a community. You have people exactly like you, senior backend engineers, junior backend engineers with you who you are going through a very similar journey. So you can ask them questions. You can get inspired by them. You can also help use them by the way to unlock more jobs if at all it comes to that. So that helps. You have a one-on-one mentor, and this is actually very important. um, I would recommend that you should schedule regular sessions with your mentor, not just because the mentor will check on with you on your progress, but the fact about somebody has to actually spend time poking on your previous experience, asking you difficult questions, on why a certain thing was done in a certain way. That your mentor can do, and can also give you feedback on how should you present your previous work, how should you present yourself. At some point of time, you'll have to build your resume. How do you build your resume which is impressive? All of that your mentor can help with. You have your one-on-one mentor, you will select that, and that's your coach in your journey, apart from your instructors and TAs. You also have TAs. They help you get unblocked whenever you're solving a problem and you get blocked. Again, also helps with completion. So, and then you have a very gamified interface, which in a way makes it very fun to come to the platform every day, solve problems, right? All of that comes together to actually help increase the probability of your completing. Now, if you want to again see numbers on what are the completion rates, etc., at Scalar, how why is this ecosystem very important? There is a link that I have attached in the description of the video. You can go and watch it. Um, However, I mean, you could also start this journey on your own with or without Scalar. There is what I would suggest is like there's there is a lot of opportunity for growth within tech. As I said, this is the blueprint for growth. Focus on your skill, focus on learning. If you do that well, then growth will happen. I hope that helps you. I hope that helps you get started with your journey. Thank you.